Hello, and welcome to the demo for VMware Tanzu SQL Postgres for Kubernetes. My name is Jemish Patel, and I am the tech lead for Tanzu SQL at VMware. Today's demo is going to focus on how we can request Postgres instances once we have a Postgres operator deployed in a Kubernetes cluster. So we will walk through and request a Postgres instance. We will look at all the K8 resources that were deployed. We will enable properties such as high availability and see what the changes are to the K8 resources that were previously deployed, and also deploy a Postgres instance in a different namespace. So let's go ahead and get started. So for today's demo, I have set up a TKG cluster running on AWS. Let me make sure that everything is running all right. And I have extracted a 1.1.0 version of Postgres for Kubernetes. And let's go ahead and install the operator. This allows us to request Postgres instances. Excellent. On the right-hand side, I am going to start a quick watch so we see what kind of K8 resources are available. And at the moment, we have one deployment with the Postgres operator that we see, which is awesome. Uh, cool. And it is in a running state. So what I'm going to do next is go ahead and request a Postgres instance. And I can do that simply by applying a example YAML that we ship anytime you download the Postgres for Kubernetes codebase or software. And I can see a lot of things spinning up on the right hand side here, but let me just see what we requested. So in this YAML, all I requested was an instance with all defaults because everything else is commented out. So all defaults and a name of PG instance example. Okay, awesome. Um, all right, I start seeing on the right hand side here, I see a Postgres instance that's in a state called created, and I see that there is a Postgres monitor that has achieved a state of running. The monitor belongs to a stateful set called the example monitor here, and and then this is where the Postgres server is actually running, and looks like it is going through its initialization process, as we see here. And sure enough, there it is, it's running, and this custom object that we have registered with Kubernetes is also changed its status to running. So it looks like everything is ready to go. Excellent. We requested a Postgres instance. What if I wanted to toggle a property? For example, what if I wanted to toggle high availability because I wanted high availability for this particular instance? I would go ahead and edit the example file and um, do that to enable high availability. Let's go ahead and apply it. And on the right hand side, I notice that my Postgres instance became pending, and I see a new pod got created for me with an index of 1. So PG instance example 1, and looks like it is going through its initialization process as well. So we'll wait till it has gotten into a better state. But that's how easy it was to simply turn on high availability. And I can do that with any of these properties that we see here. You know, I can scale memory, CPU, um, service type. At the moment, it's assigned to be a load balancer service type, or enable backups as well, just by uncommenting properties and applying the YAML. And sure enough, on the right-hand side, I see that my new pod has gotten to running, and the Postgres object as well has changed its status to running. So that's awesome. Um, Now, what if I wanted to make a request to another namespace? Right now, everything's in the default namespace. Um, I could add a property here called namespace, but I can do something better. Why don't I can just use the same file and append a namespace here. I have created a namespace called Jemish. I will go ahead and hit apply there. And on the right hand side, let's watch everything that's coming up in this namespace now. And sure enough, I see a Postgres instance object getting created. I do see a monitor pod um, having a status of initialization. Oh, it just switched to running. And looks like we should be getting another pod. Because HA was enabled, I'm getting two pods at this point as well, and they're both kind of going through their initialization process. So let's take a look at how many instances we have. And just take a look. And they're enough. There I have two instances, looks like the same name, but they're in two different namespaces. The connection coordinates for the Postgres instance object are in a secret object that we create inside of Kubernetes, and this was created for us by the Postgres operator. This is where you can find connection URI or you know username, password type authentication credentials that you can use to connect to the deployed instance. One other thing I wanted to also show is we saw that there was a monitor pod along with two other pods where the Postgres servers were running. What was the monitor doing? And monitor simply is tracking HA state for us. And one way to quickly view that HA state is ask it for state information like so. And so it's tracking if synchronous replication is happening correctly across the primary Postgres server as well as the secondary Postgres server, and which pod is playing which role. In this case, the example 0 pod is the primary, and example 1 pod is the secondary. Awesome. So that concludes my demo. Recap what we just saw. We saw how simple and easy it is to request a Postgres instance once we have a Tanzu Postgres operator installed in our Kubernetes environment. We looked at all the K8s resources that the operator created for us for every request of a Postgres instance. We learned how to change properties of the Postgres instance by enabling high availability. We checked out all the new pods that had spun up for us when we enabled HA. And we also requested Postgres instances in a different namespace. That concludes the demonstration for today. Thank you, and I hope you enjoyed watching.